Welcome to our last lecture for CAD, where we're briefly going to go over how to do a dynamic modal analysis. So we're going to look at some vibration related aspects. SOLIDWORKS will help you be able to figure out your resonance frequency, the natural frequency, things that you cover in vibrations. What we're going to do is we're going to look at the natural frequencies and mode shapes of a cantilever beam. We're going to do it, I believe, for the free beam and for a beam that has a weight at the end of it. We can work on a preliminary analysis based on strength of materials with Hooke's law to give us deflection. We can also use some of our vibrations knowledge to figure out the natural frequency, which is our stiffness divided by our mass. The equivalent mass is determined from the continuous system analytical approach. It's going to be based on E and I and its length. So there's at least 3 mode shapes for this beam. You can look in the book. We are in the FEA book again, or your vibrations book. For the system, we are considering our natural frequencies would be 19.71 Hertz, 121.85 Hertz, and 341.22 Hertz. If we put the mass on the end of it, we'll get some slightly different numbers. The book also has a software that allows you to create some mode shapes, but we're going to focus on how to do this in SOLIDWORKS. So I'm going to create a new part in SOLIDWORKS. And on my right plane, I'm going to make a new sketch of a rectangle. I'm going to use the 2-corner method. One at the origin, one up further away. I'm going to put some dimensions on this. This is going to be 1 inch by 0.125 inches. And then I'm just going to move this back down to the origin because that's where I like things. Apparently I hadn't quite grabbed the origin when I first set this up. We're going to exit our sketch and we are going to extrude our sketch a total of 14.5 inches. So now we have our relatively long, thin model. We are going to make a new study, and instead of using a static study, we're going to use a frequency study. And click OK. We're going to apply material to this part. This part is going to be alloy steel. we are going to put a fixture on the left end to make it our cantilever beam. So for the initial run, we don't need to put an external load on it. We're going to be able to find the natural frequency, which is a property of our system that we created. I'm going to create a mesh. I'm going to use a standard mesh with 0.25 and 0.0125. So this mesh has about 3,221 out nodes and 141,440 solid elements. So I'm going to go ahead and run this study. And here we have our answer. Let's list our frequencies first, and then we'll look at mode shapes. So if I right click on results, I can list resonant frequencies, and here it has our modes and our frequencies. If we look at hertz, we get 19.8. So one thing to note is the third mode shape that SOLIDWORKS is giving us doesn't really match our third mode shape from hand, but you have to remember there are mode shapes that exist outside of the plane that we looked at. So besides also comparing mode shapes, we're going from natural frequencies, we're going to look at mode shapes. When you make an amplitude mode shape, let's click edit here, it's going to ask you the frequency and the mode shape. If we do that, we have this first graph. We can also click through them. So this is mode shape 2, 1, 2, 3, 5, 1, 2, 3, 4, 5. Yeah. Naturally, you then want to do mesh refinement, which I'm not going to do because of the interest of time. What we're going to do is we're going to add an additional mass to this system. I'm going to go back to my 3D model. I'm going to click on this top surface, and I'm going to create a sketch. This is going to create a sketch referenced to the top surface, and I'm going to put a rectangle wrong type of rectangle. On this corner to give me a place to put my remote mass. I'm going to emboss extrude this sketch upwards of 1.77. So we've basically created a nice little weight here. If I go back to our frequency study, we now have a weight on here. We have some warnings. Basically, our mesh is out of date, so let's create a mesh.